This is the video for section 5.2 notes, slides 7 through 10. All right, in section 5.2, we are studying the context of position, velocity, and acceleration. So motion of objects. A lot of times in physics, you guys cover a lot to deal with projectile motion. So how objects behave when they are subject to the force of gravity, which is, of course, something that you might be asked, but it's actually more than likely that you're not going to be asked that. You would just be asked about motion, given the velocity or acceleration or position of something else. What we need to know is a couple things. Number one, we need to know that velocity is the derivative of the position function. So v of t is equal to s prime of t. Or we should know that using a different notation, v could be noted as ds dt. S is often used as the position variable, so s of t. Okay. Now, speed, remember, is the absolute value of velocity, right? So velocity, remember, is a vector, so that means positive means forward and negative means backwards, or positive means right and negative means left, or positive means up and negative means down, whatever. Speed is not a vector. It is a scalar, which means that it only has a value and not a direction. So speed is the absolute value of velocity. All right. And then acceleration, of course, is the derivative of velocity, which means that a of t is v prime of t, which is also s double prime of t. But remember that a could be written as dv dt, or it could be written as d dt of ds dt, which, of course, we would also remember would be d squared s dt squared, right? So we want to make sure we keep those things in mind, what those different notations might mean. All right, so we understand that, but now we want to make sure we understand how all of these kind of function, but also within the context of what we've done in Unit 4 and other things. So let's say that we're looking at just an example of a graph of an S versus T. So that would be position versus time. All right. And so let's just say that I have a graph that looks like this. Yes, it looks like the sine function, but it doesn't have to be a sine function. It could just be any function. All right. And so we're starting off at 0, and then we're going to name some of these locations. So A is here. Let's say B is here. C is here, and D would be here, right? So we're starting at 0, going to A, going to B, going to C, going to D. All right, so what can we say about this graph? All right, so number one, all right, from 0 to A, the position is increasing, right? Because this thing is moving upwards, right? So what can we say there? We can say that velocity is greater than 0, right? All right. But also we can say, because this curve is concave down, that means its second derivative is negative. In other words, a is less than 0. All right. So then what happens after a? Well, from A to B, right, position is decreasing. So velocity is less than 0. And, of course, acceleration. Well, this curve is still concave down, so a is also less than 0. All right, so position is decreasing. All right, now what happened at B? Well, at B, the object is back at its origin, right? Its position is 0. Then it continues to decrease its position, meaning what? Meaning now it is traveling backwards still, but now it is like to the left of where it started or below where it started, depending on what we're thinking. All right, so now between B and C, what is going on? Well, position is still decreasing, which means velocity is less than 0. And now the curve is concave up, so acceleration is greater than 0. All right, what happens after C? Well, from C to D, now position starts increasing, so velocity is positive. All right, and then acceleration, well, it's still concave up, so acceleration is positive as well. All right, so that's some of the basics, right? Analyzing the curve of position. All right, so let's first of all take, what we know about velocity. All right, so first of all, I want to do a really basic sign analysis of velocity. All right, so sign analysis of velocity. All right, so velocity is 0 at A. right, than it is 0 at C, right? So remember, velocity is the slope of this graph, right? So it is positive from 0 to A, it is negative from A to C, and it is positive from C to D. So what is actually happening here? Well, from 0 to A, we're traveling to the right, or up, or whatever, right? From A to C, we're traveling to the left. And then from C to D, we're traveling back to the right again. All right. So this is what we can say, right, is the motion of the object, right? So now what we do is we actually have something that we're going to call a motion diagram, okay, which indicates where we are at any particular time. All right. Now, A, B, C, D, those are times, right? So starting off, we are at a position of 0, okay? So we're going to start off here when t equals 0 at a position of 0. So from 0 to A, we are traveling to the right. So I'm going to put a little arrow here. We're traveling to the right. At A, what happens? So t equals A, we actually turn around and we start traveling to the left. How did I know that I was traveling to the left? Well, because now velocity is negative. So velocity is negative, right? Right here at t equals B, we pass through our origin, right, our starting location, and then we continue to travel to the left until we get to t equals C, where we stop and we turn around and we start traveling back to the right, and then we get back to our origin at t equals D, right? So now, at what time were we furthest to the right? Well, at t equals A, we were furthest to the right, so we could say that's our max, and at t equals C, that would be our minimum based upon this graph. So this is what we call a motion diagram. All right. So now we also want to discover a little bit about speed and acceleration. All right. So I'm going to redraw this graph. All right, just so I can kind of think about it. All right. So same graph, same values, A, B, C, and D. All right. And this is still position versus time. All right. So now what's going on from 0 to A? What's going on from 0 to A? Now remember, at A, what happens? We said you're increasing your position, right? So down here, and then you stop and you turn around and then you start traveling backwards. So here's when we stop, okay? Where else do we stop? Well, we stopped at C, right? Remember, it's a momentary stop. It's like we just stop and instantly turn around, okay? All right, so now think about this. From 0 to A, if you're going to stop at A, what must happen before you stop? Well, interesting thing, a lot of people understand that question. You must slow down, right? You must slow down before you stop, right? Right? If the function is continuous, right, and differentiable, right, you have to have slowed down before you stopped, right? Now, if you stopped and then you were in motion again, what do you have to do? Well, you have to speed up, right? So you were slowing down and then you were speeding up. Now, at B, the fact is that you stop speeding up and then you start slowing down again. How do you know I slowed down? Well, because at C, I'm going to stop, so I must be slowing down, right? That's the logical progression, right? But then after I stop at C, in order to start moving again, I must speed up. Okay. Now, some of you are like, well, I don't know. I'm not so sure. So let's examine